It's December 5, 1945. Five military aircraft take off from Fort Lauderdale, Florida, for what should be a routine training mission. Within hours, all 5 planes and their 14 crew members vanish without a trace. No wreckage, no distress signals, no survivors. This is Flight 19, and it's just one of dozens of mysterious disappearances that have given birth to one of the world's most enduring mysteries, the Bermuda Triangle. For nearly 8 decades, this stretch of ocean has captured our imagination, spawned countless theories, and left us wondering, what really happens to planes and ships that enter this cursed waters? But what if I told you that everything you thought you knew about the Bermuda Triangle was wrong? What if the real story behind these disappearances isn't supernatural at all, but something far more surprising? Today we're going to dive deep into the science, the statistics, and the shocking truth that scientists have been trying to tell us for years. By the end of this video, you'll never look at the Bermuda Triangle the same way again. Let's start with what we think we know. The Bermuda Triangle, also known as the Devil's Triangle, is supposedly a loosely defined region in the western part of the North Atlantic Ocean, where ships and aircraft have allegedly disappeared under mysterious circumstances. The area is roughly bounded by Miami, Bermuda, and Puerto Rico, creating a triangular shape that covers approximately 500,000 square miles of ocean. That's larger than the entire state of Texas, floating in some of the busiest shipping and aviation corridors in the world. The legend tells us that more than 50 ships and 20 aircraft have vanished in this area, often in good weather and without sending distress signals. Compasses spin wildly, electronic equipment fails, and vessels simply vanish as if swallowed by the ocean itself. The stories are compelling. Christopher Columbus reportedly saw strange lights and experienced compass problems in these waters back in the USS Cyclops, a massive naval cargo ship, disappeared in 1918 with 306 people on board, never to be seen again. And then there's Flight 19, the incident that really put the Bermuda Triangle on the map. But here's where things get interesting. In 2025, scientists have access to decades of research, advanced statistical analysis, and comprehensive maritime data that tells a completely different story. Dr. Karl Kruszelnicki, a respected scientist from Sydney University, has been studying the Bermuda Triangle for years, and his findings might shock you. According to his research, backed by Lloyd's of London and the US Coast Guard, the number of planes and ships that go missing in the Bermuda Triangle is exactly the same as anywhere else in the world when you account for traffic volume. Let that sink in for a moment. The Bermuda Triangle isn't mysterious at all. It's statistically normal. Think about it this way. Imagine you're standing on a busy highway counting accidents. If you stand on a stretch of road where thousands of cars pass every day, you're going to see more accidents than on a quiet country road where only a few cars pass each week. But that doesn't make the busy highway cursed. It's just basic probability. The Bermuda Triangle sits in one of the most heavily trafficked areas of ocean in the world. Every single day, hundreds of aircraft fly through this airspace, and countless ships navigate these waters. Miami International Airport alone handles over 45 million passengers annually, and the Port of Miami is one of the busiest cruise ports in the world. When you crunch the actual numbers, something fascinating emerges. The US Coast Guard, which responds to maritime emergencies in this region, reports that they conduct approximately 8,000 search and rescue missions annually in the waters around Florida and the Caribbean. Of these thousands of incidents, the vast majority have perfectly logical explanations: mechanical failures, human error, severe weather, or simple accidents. The success rate for navigation through the so-called Bermuda Triangle is over 99.9%. That means for every supposed mysterious disappearance, millions of vessels and aircraft pass through safely. But if the statistics don't support the mystery, why do we still believe in it? The answer lies in a powerful combination of psychology, media sensationalism, and our natural human tendency to find patterns where none exist. In the 1960s and 1970s, authors like Vincent Gaddis and Charles Berlitz wrote best-selling books about the Bermuda Triangle, cherry-picking incidents and embellishing details to create a compelling narrative. They ignored the thousands of safe passages and focused only on the incidents that seemed unexplainable, creating a classic case of confirmation bias on a massive scale. The media latched onto these stories because mystery sells. Television documentaries, magazine articles, and later, internet content creators found that Bermuda Triangle stories generated massive interest. Each retelling added new layers of mystery, often stretching facts or omitting crucial details that would explain the disappearances. Before long, the legend had taken on a life of its own, spreading faster than the actual facts could keep up with. Let's examine some of the specific environmental factors that make this region challenging for navigation, because the truth is actually more fascinating than the fiction. The Bermuda Triangle sits directly in the path of the Gulf Stream, one of the strongest ocean currents in the world. This massive river of warm water moves at speeds of up to 4 miles per hour and can cause sudden dramatic changes in weather conditions. Imagine flying through an area where the weather can shift from calm to stormy in minutes, where warm air masses collide with cold ones to create dangerous microbursts and downdrafts. The geography beneath these waters is equally treacherous. The area contains some of the deepest parts of the Atlantic Ocean, including the Milwaukee Depth, which plunges down nearly 28,000 feet. When aircraft or ships encounter problems in these waters, wreckage can sink to depths so extreme that recovery becomes nearly impossible with current technology. This explains why some disappearances seem so complete. The evidence literally disappears into some of the deepest, most inaccessible parts of our planet's oceans. Weather patterns in this region are notoriously unpredictable. The area is frequently hit by tropical storms and hurricanes, which can develop rapidly and with little warning. Even in the age of advanced meteorology, weather systems can intensify faster than forecasters can track them. A pilot or ship captain might enter the area in seemingly perfect conditions, only to encounter a sudden storm that develops in the time it takes to cross a small section of ocean. Then there's the phenomenon of rogue waves, massive walls of water that can appear seemingly out of nowhere. These giants, sometimes reaching heights of 100 feet or more, are created by the interaction of different wave systems, ocean currents and wind patterns. For a ship, encountering a rogue wave is like running into a moving skyscraper made of water. They can appear faster than a crew can react, and they've been known to sink large vessels in minutes. The human factor plays an enormous role in these incidents as well. Navigation in the waters around the Bermuda Triangle presents unique challenges. The area where the incidents allegedly occur is characterized by shallow shoals and reefs that can appear suddenly, especially during low tide. Inexperienced boaters and pilots can find themselves in dangerous situations quickly. Add to this the fact that many of the reported incidents occurred decades ago, when navigation technology was far more primitive than today's GPS systems and weather forecasting capabilities. Let's talk about Flight 19 specifically, because it's often cited as the most mysterious Bermuda Triangle incident. On December 5, 1945, 5 Grumman TBF Avenger torpedo bombers took off from Naval Air Station Fort Lauderdale on a training mission. The flight leader, Lieutenant Charles Taylor, was an experienced pilot, but he was unfamiliar with the area. During the flight, Taylor's compass began malfunctioning, not unusual for military aircraft of that era, which often had compass problems due to the magnetic interference from the aircraft's metal components. As the flight progressed, Taylor became increasingly disoriented. Radio transmissions revealed that he believed he was flying over the Florida Keys when he was actually over the Bahamas. This is a crucial detail that's often omitted from sensationalized accounts. When another pilot suggested flying west to reach the Florida coast, Taylor, believing he was already south of Florida, ordered the flight to continue east and north. This decision led them further out over the Atlantic Ocean, away from land and safety. Weather conditions deteriorated rapidly that evening, with high winds and rough seas developing across the area. The aircraft eventually ran out of fuel over the open ocean. A rescue aircraft, a PBM Mariner flying boat, was dispatched to search for the missing flight, but also disappeared. However, this second disappearance isn't mysterious either. Several ships in the area reported seeing an explosion in the sky around the time the Mariner would have been in the search area. The PBM Mariner was known to have fuel vapor issues that made it prone to explosions, earning it the nickname the flying gas tank among crews. What makes this case seem mysterious is that no wreckage was ever found. But this isn't supernatural, it's geography. The aircraft went down in extremely deep water during a storm. Ocean currents in the area are strong enough to disperse wreckage over hundreds of miles within days. Even today, with our advanced technology, finding aircraft wreckage in deep ocean waters remains incredibly challenging and expensive. Malaysia Airlines Flight 370, which disappeared in 2014, took years to locate despite modern satellite tracking and international search efforts. The USS Cyclops presents another case often cited as mysterious, but the facts tell a different story. This massive naval cargo ship disappeared in March 1918 while carrying a full load of manganese ore from Barbados to Baltimore. The ship was overloaded, carrying more cargo than it was designed for, and the manganese ore was known to shift during rough seas, causing vessels to become unstable and potentially capsize. The Cyclops had a history of mechanical problems, including issues with one of its engines. The ship disappeared during World War I, when German submarines were actively hunting Allied vessels in the Atlantic. While no German records confirm sinking the Cyclops, wartime records from that period are often incomplete. More importantly, two sister ships of the Cyclops, the Proteus and the Nereus, also disappeared in the same area during World War II, while carrying similar cargo loads. This pattern strongly suggests structural or operational problems with this class of vessel, rather than supernatural causes. Modern naval architects, who have studied the Cyclops class, believe these ships had fundamental design flaws that made them prone to catastrophic failure under certain loading and weather conditions. When we examine the evidence objectively, patterns emerge that point to natural causes rather than supernatural ones. The majority of disappearances occur during periods of severe weather. Most involve aircraft or vessels that were already experiencing mechanical problems or navigational difficulties before entering the area. Many of the incidents happened decades ago, when safety equipment, communication systems, and weather forecasting were far less sophisticated than today. The National Oceanic and Atmospheric Administration, which monitors maritime safety, has stated definitively that they attribute the incidents in the Bermuda Triangle to environmental factors such as hurricanes, sudden weather changes from the Gulf Stream, and in the area's many shallow reefs and shoals. The U.S. Navy has completely dismissed supernatural explanations, citing natural causes and human error as the primary factors in maritime incidents in the region. Perhaps most tellingly, the rate of disappearances in the Bermuda Triangle has decreased dramatically as technology has improved. Modern GPS systems make navigation errors less likely. Advanced weather forecasting gives pilots and ship captains better information to avoid dangerous conditions. Improved communication systems mean that vessels in distress can quickly call for help. Satellite tracking means that even when accidents do occur, rescue teams can respond faster and more effectively. This technological improvement tells us something important. If the Bermuda Triangle were truly supernatural, better technology wouldn't matter. Mysterious forces wouldn't be deterred by GPS or satellite phones. The fact that fewer incidents occur as our tools improve strongly suggests that the historical disappearances were due to the technological limitations of their time, not supernatural causes. The psychological appeal of the Bermuda Triangle mystery reveals something fascinating about human nature. We love mysteries, especially ones that suggest there are still unknown forces in our modern, well-mapped world. The idea that there's a place where our technology fails and our understanding breaks down is both terrifying and exciting. It suggests that despite all our scientific advances, there are still frontiers of the unknown. This attraction to mystery isn't necessarily bad. It's driven scientific inquiry and exploration throughout human history. The problem arises when we prefer the mystery to the truth, when we ignore evidence in favor of more exciting explanations. The real story of the Bermuda Triangle is actually more impressive than the legend. It's a story of how human beings learned to navigate some of the most challenging waters on Earth, how we developed the technology to predict weather patterns and avoid dangerous conditions, and how scientific investigation can solve seemingly impossible puzzles. The truth about the Bermuda Triangle also teaches us valuable lessons about critical thinking and media literacy. In our age of instant information and viral content, sensational stories can spread faster than facts. The Bermuda Triangle mystery persisted for decades, partly because the tools to easily verify claims and access original sources weren't available to most people. Today, we have access to Coast Guard records, weather data, and statistical analysis that our grandparents could never have accessed. Looking at this case study, we can see how important it is to ask the right questions when we encounter extraordinary claims. Instead of asking how can we explain these mysterious disappearances, we should ask, are there actually more disappearances here than in other similar areas? Instead of focusing on the incidents that seem unexplainable, we should look at the complete picture, including all the successful passages through the area. The Bermuda Triangle story also highlights the importance of understanding statistics and probability. Humans are notoriously bad at assessing risk and understanding random events. We see patterns where none exist and assign meaning to coincidences. When we hear about several plane crashes in a short period, we assume something unusual is happening, even though such clusters are perfectly normal in random distributions. As we wrap up this deep dive into the Bermuda Triangle mystery, it's worth reflecting on what we've learned. The disappearances attributed to the Bermuda Triangle aren't supernatural. They're the result of a perfect storm of factors: heavy traffic, challenging environmental conditions, technological limitations of past eras, and our human tendency to create patterns and stories from random events. The real Bermuda Triangle is neither cursed nor magical. It's a busy section of ocean with normal risks that have been magnified by selective reporting and human psychology. Ships and planes that encounter problems there face the same challenges they would anywhere else: mechanical failures, severe weather, human error, and the vast, unforgiving nature of the ocean itself. But perhaps the most important lesson from the Bermuda Triangle isn't about navigation or maritime safety. It's about the power of scientific thinking and the importance of evidence-based conclusions. When scientists like Dr. Karl Krushelnicki took the time to examine the actual data rather than repeating the stories, they found that the mystery dissolves under scrutiny. The Bermuda Triangle teaches us that extraordinary claims require extraordinary evidence, and that sometimes the most extraordinary thing about a mystery is how ordinary the explanation turns out to be. In our modern world, where misinformation can spread as quickly as truth, the Bermuda Triangle serves as a perfect case study in the importance of critical thinking. It reminds us to question sensational claims, to look for primary sources, and to trust scientific evidence over compelling stories. The next time you encounter a modern mystery, whether it's about health, technology, or world events, remember the lessons of the Bermuda Triangle. Look for the data, question the narrative, and don't let a good story override good evidence. The ocean will always be dangerous, and aircraft will always face risks, but the Bermuda Triangle isn't any more dangerous than other heavily traveled areas of similar size. The mystery was never in the ocean itself. It was in our minds, in our love of the unknown, and in our willingness to believe extraordinary stories without extraordinary proof. And perhaps that's the most human truth of all. Sometimes we create mysteries because we need them, because a world with unexplained phenomena feels more magical than one where everything has a rational explanation. The real magic isn't in supernatural disappearances. It's in the human capacity to solve puzzles, seek truth, and ultimately choose facts over fiction, even when the fiction is more entertaining.